When people first began mapping the world, the Pacific Ocean looked like a vast, empty space. Between the continents lay a vast blue expanse, devoid of cities, roads, or borders, only water. Even today, in the age of satellites and global navigation, this ocean remains the largest and least explored region of the planet. The Pacific Ocean covers almost a third of the Earth's surface. If it were a separate continent, it would be larger than all the other continents combined. The distance from the shores of South America to Asia is over 10,000 kilometers, and between the islands in its central region, there are sometimes thousands of kilometers of open water. But scale is only part of the story. Another world lurks beneath the surface of this ocean. At a depth of several kilometers lie vast plains, stretching for hundreds of thousands of square kilometers. There are no mountain peaks, no familiar landmarks, only a soft layer of sediment that slowly falls from the upper layers of the ocean, like sparse snow in the darkness. In other areas, the ocean floor is cut by gigantic canyons, deeper than many mountain valleys on land. There are underwater mountains whose peaks have never seen sunlight. There are also crustal fissures where hot, mineral-rich water emerges from the depths of the planet. But the most amazing thing is the depth. In some places, the Pacific Ocean plunges more than 10 kilometers. It's a distance hard to imagine. If you lowered the highest mountain on Earth, Everest, into the ocean, its peak would still be deep underwater. At this depth, the pressure exceeds 1,000 atmospheres. This means that every square centimeter experiences a force comparable to the weight of a small car. Light cannot penetrate. The water temperature is close to zero. For a long time, scientists believed that life was impossible in such conditions. But the ocean proves otherwise again and again. Every decade, researchers discover new life forms in its depths. Transparent creatures, strange fish, bacteria that can survive without sunlight. Many of them look so unusual that they seem to come from another world. Yet the most surprising thing is how little we know about this vast space. Much of the ocean floor remains unexplored. Modern depth maps are often created not by direct measurements, but by indirect methods. For example, by studying changes in the Earth's gravitational field. This means that vast areas of the ocean remain virtually unknown. This is why there are places in the Pacific Ocean that scientists and researchers call mysterious. Some of them are astonishing in their depth. Others are absolutely remote from land. There are places where instruments have recorded strange sounds, the source of which remained unknown for a long time. There are also areas where unusual ecosystems are discovered on the seabed, existing without sunlight. These places are rarely visited by people. Some expeditions head there only once every few decades. Sometimes deep-sea vehicles descend for the first time into areas that remained completely isolated from the surface for millions of years. Each such dive is a journey into an unknown world, a world where cold darkness reigns, where pressure can destroy any unprepared equipment, where life develops according to its own laws. It is in this ocean that the deepest place on Earth is located. It is also home to what is considered the most remote point on the planet, and it was here that scientists recorded one of the most mysterious sounds ever heard in the ocean. Today we will go on a journey to these places. We'll descend into the Mariana Trench, the deepest point on the planet. We'll visit Point Nemo, the most isolated place on Earth. We'll learn the story of the strange signal known as Bloop, and we'll see a world that exists far below the surface, in the cold silence of the ocean depths. This is a journey to one of the last unexplored worlds of our planet, a world hidden under kilometers of water, a world where even today many mysteries remain. There's a place in the Pacific Ocean that doesn't resemble conventional geography. It doesn't look like an island or an archipelago. It's invisible to the naked eye, and there are no lighthouses marking it. Its presence is felt not by the eye, but by numbers, depth, pressure, cold, and absolute darkness. The Mariana Trench isn't a pit in the usual sense. It's a long, narrow zone of crustal rupture and subsidence, stretching for thousands of kilometers in the western Pacific Ocean. There, an oceanic plate slowly subducts beneath its neighbor, as if the planet were inhaling and drawing part of its surface back into the depths. This process has been going on for millions of years. It doesn't look like a catastrophe because humans can't directly see it. But this is precisely how the Earth changes shape, slowly, inevitably, almost silently. When people talk about the Mariana Trench, they most often mean one point: Challenger Deep, the deepest part of the trench. Depth figures may vary slightly between sources as measurements are refined, instruments become more accurate, and the ocean floor isn't perfectly flat. But the order of magnitude remains consistent. Approximately 11 kilometers down. 11 kilometers is a distance humans are accustomed to perceiving as upward, not downward. Passenger planes fly at an altitude of 10 to 11 kilometers. This is the familiar flying altitude. But here, the same scale is directed not toward the sky, but toward the darkness. And this is precisely where the change in orientation disrupts the imagination. Familiar dimensions begin to sound different. Even if Everest were placed at the bottom of the Mariana Trench, the mountain's peak would still never emerge. It would remain underwater. This comparison works not as a beautiful image, but as a way to physically experience depth. The trench isn't deeper than the ocean, but a different class of space. Now let's add pressure. On the surface, we live under one atmosphere. This is a pressure to which the body has become so accustomed that we don't feel it. But water is denser than air, and every meter of depth adds its share of pressure. At a depth of 1,000 meters, the pressure reaches hundreds of atmospheres. At a depth of 11 kilometers, it exceeds 1,000 atmospheres. That is, more than 1,000 surfaces are pressing down on us simultaneously. If you imagine this as a load, then every square centimeter is subject to a mass comparable to the weight of a small car. And this isn't just a figurative comparison. It's the actual physical meaning of pressure at such a depth. Any cavity, any weak point, any air bubble becomes a problem. Ordinary glass wouldn't withstand even a fraction of this pressure. Ordinary metal would deform. Any device without special protection would be crushed almost instantly. This depth isn't thaw. It's hostile to any space within. Therefore, the deep-sea vehicles that descend there are almost always built around a single concept: a small, extremely durable sphere or capsule for a person and instruments, while everything else serves as a shell, support, balancing, and communication. All engineering boils down to giving a person a few cubic meters of dry world amidst thousands of atmospheres. But even if the technology holds up, another question remains: what is there anyway? For a long time, it was believed that life was impossible at such depths. The logic was simple. No light means no plants and no photosynthesis. Extreme cold means reactions are slower. Pressure destroys the natural structure of proteins and cells. Food is scarce because everything organic must fall from above, travel through kilometers of water, and dissipate. And yet, the ocean has proven time and time again that life doesn't have to be comfortable or like ours. The first attempts to explore such depths were almost blind. Before echo sounders and modern instruments, people measured depth using sounding lines, lowering weights on a cable. This took hours and yielded approximate values, but gradually it became clear the Pacific Ocean contained zones that extend much deeper than previously thought. The Mariana Trench became a symbol of this limit. Then came 1960. The bathyscaphe Trieste, carrying Jacques Picard and Don Walsh, made a historic dive to the deepest point. This journey is especially impressive if you think of it not as a heroic event, but as a sequence of sensations. First, the surface, the light, the familiar world. Then comes the gradual fading of the light, the water changing from light blue to dark blue, then to almost black. The apparatus descends for hours. Outside the porthole, it's not the landscape that changes, but the very concept of visibility. At first, you can still see particles, bubbles, and sometimes the silhouettes of fish, but at a certain depth, only darkness remains. There is no difference between day and night. It is always night. At great depths, another feeling emerges, a lack of scale. On land, we always have landmarks, tree lines, mountain outlines, walls. Underwater, especially in the dark, landmarks disappear. All that remains are the numbers on the instruments and the occasional dots in the beam of light. It's like falling into empty space, not quickly, but slowly, hour after hour. When the Trieste reached the bottom, the explorers saw a smooth sediment surface, soft silt. The searchlight illuminated a small circle, and beyond it was absolute darkness. At that moment, one of the most famous episodes occurred. They spotted movement, something resembling a fish. The details of this observation were debated later, as fish are rare at such depths, and the question of what exactly was observed remains elusive. But more importantly, the very idea that life could exist at depths seemingly impossible ceased to be a fantasy. After this dive, a long time passed before humans began systematically returning to these depths. The reason is simple. It's expensive, difficult, and risky. The depths are unforgiving. Any leak in the seal is not an accident, but an immediate disaster. Therefore, for many decades, the Mariana Trench remained more of a symbol than a site of regular exploration. But the symbol attracts. In the 21st century, technology became more reliable, new materials, new communication systems, new methods of seafloor mapping, and autonomous vehicles emerged. A new wave of deep-sea expeditions began. One of the most famous solo dives was the 2012 dive of James Cameron on the deep-sea submersible. Challenger has reached the bottom of Challenger Deep. What's important isn't that he's the director, but that he did it alone, in a confined space, at the limits of technology, in a place where there's no quick rescue. At depth, rescue is always theoretical. Practically, you have to get back out yourself. Cameron described the sensation of the bottom as desolate and alien. Soft sediment, the absence of familiar landforms, very limited visibility, and a silence unlike the silence on dry land. On dry land, silence is the absence of surrounding sounds. In the depths, silence is the absence of the world we're accustomed to. No wind, no birds, no distant city noises. There's only you, the apparatus, and the occasional creaking of the structure that holds the pressure. Modern expeditions, including commercial and scientific, have descended into the trench since then. Some projects sought not just to reach the bottom, but to conduct a series of dives, film, collect samples, and compile more accurate maps. And here begins the true mystery of the trench, not the mythical, but the scientific one. The ocean floor at its deepest point is not a sterile place. On the contrary, sample analysis reveals the presence of microorganisms that have adapted to extreme pressure. Some life forms at depth don't live as we typically imagine active life. They don't run or hunt in the traditional sense. They exist slowly. Theirs is a world of waiting, where food is rare and energy is precious. The most unexpected fact of recent decades is that even there, at the very bottom of the planet, traces of human civilization are being found. Not in the form of ships, of course, but in the form of microplastics and chemical pollutants. It sounds almost absurd. The most remote and deep place, where almost no one has descended, turns out to still be connected to the surface. But the ocean is a system. Anything that enters the water can travel, particles can sink, be carried by currents, and settle. This thought alters the perception of depth. It ceases to be an alien universe and becomes a mirror of the planet, into which almost everything eventually ends up. There's another mystery. Why can life withstand such pressure at all? At the molecular level, pressure affects protein structure, cell membranes, and chemical reactions. To survive, organisms must have special adaptations. Deep-sea creatures lack gas pockets that could collapse or rupture. Their tissues are softer, their chemistry is tuned differently. They don't live at the limit, but within a normal range. It's just that this normal range is where humans reach their limits. Yet the Mariana Trench remains mysterious for another reason. We have seen too little. The ocean surface area is vast. Even a single basin isn't a single point, but an entire world with distinct microzones, differences in sediments, topography, and organic sources. We see tiny spots in the spotlight, as if shining a flashlight across a vast field at night, and thus try to understand the entire landscape. And each new descent is not a repetition, but a new chance to see the unexpected. The basin is also a geological space where the planet is at work. Subduction means the Earth's crust is moving downward, rocks are deforming, and earthquakes are occurring. This isn't necessarily evident on the surface right now, but over time, the basin is an active zone. And somewhere there, beneath layers of sediment and rock, the processes that shape the face of the Earth continue. When we call the Mariana Trench a mysterious place, it's not a myth. It's a combination of extreme conditions and a lack of knowledge. We know the depth figures. We know individual dive reports. We know there's life there. But we don't know how diverse this world is, how it's changing, what life forms have yet to be recorded, what chemical processes occur in the sediments, what unknown adaptation mechanisms exist in microbes and in vertebrates. And finally, there is one more mystery: human. Why are people so drawn to the bottom? Why does a place where there's no light, where it's cold, where the pressure can crush metal, become a symbol? Probably because it's a rare physical limit. On land, there are limits too, but they can be circumvented. In the depths of the ocean, the limit is absolute. Either you build the right apparatus, or you simply won't be there. Therefore, each descent into the Mariana Trench is not just a scientific event, but a reminder. There are places on our planet where humans are still not masters. If the Mariana Trench is striking in its verticality, its depth, descending for kilometers, then Point Nemo is striking in its horizontality. This place isn't about the pressure and darkness of the seafloor. It's about the distance that can't be seen, but can be felt. Point Nemo is an oceanic pole of inaccessibility, a point in the South Pacific Ocean that is the farthest from any land. It was never discovered by explorers. Ancient maps do not refer to it. It arose not as part of a legend, but as a result of calculation. At the end of the 20th century, when digital coastline maps became sufficiently accurate, someone decided to find the geographic limit in the water. Engineer and surveyor Hervoyer. In 1992, Lucatella tackled a mathematical problem, determining the point on the ocean surface that would maximize the distance to the nearest land. This wasn't a compass-based exercise, but rather an algorithm-based one. The computer iterated over coordinates, measured distances along the arc of the globe, compared the possible solutions, and searched for the maximum. And I found it. The closest landmasses turned out to be 3 remote islands, each of which seems like the edge of a map. Ducie Island, Pitcairn Islands, Motu Nui off Easter Island, and Maher Island off the coast of Antarctica. Each is roughly the same distance away, about 2,500 kilometers. The number sounds familiar until you think of it in oceanic terms. 2,500 kilometers is several days sailing for a large vessel and an eternity for a small boat. This is the distance at which the very idea of shore disappears. In a normal sea, we think, somewhere out there, beyond the horizon, there is land. Here, there are many horizons encircling the vessel, but somewhere out there is too far away to be a real reference point. Land becomes not a reality, but a concept. The point was named after Captain Nemo, a Jules Verne character. The name turned out to be remarkably accurate. Nemo translates as nobody, and indeed, within 1,000 kilometers of this point, there's almost never anyone. Not because it's inaccessible, but because there's rarely a reason to go there. The South Pacific is not a highway. The main trade, fishing, and passenger routes run further north. There are no major ports because there is no continent nearby. There is no island chain that would naturally form routes. There is a vast, almost uninterrupted expanse of ocean. If you imagine the ocean as a system of slowly moving circles, Point Nemo is located inside the South Pacific Gyre. This is a gigantic system of currents, slowly rotating clockwise. It is shaped by winds, the Earth's rotation, and the distribution of continents. Within the gyre, water moves in enormous arcs. This is not a vortex visible to the naked eye. It is a planet-scale movement, measured in centimeters per second, but covering millions of square kilometers. Oceanographers often note one characteristic at the center of the gyre: comparatively low biological productivity. This region is called an ocean desert, not because there's no life there, but because there are fewer nutrients. In coastal areas, currents stir up deep water, rich in minerals and trace elements. This feeds phytoplankton, which are the basis of the food chain. At the center of the gyre, such upwellings are fewer. The water is more stable, poorer. This means less plankton, less fish, and fewer birds. Therefore, those who passed through the sea here often noted one thing: emptiness. The emptiness isn't just visual, it's biological as well. During the day, there might not be a single ship, a single bird, or a single splash to remind you of life. Only water and sky. This doesn't mean life disappears entirely. The ocean always contains it, at least on a microscopic level. But the sense of sparseness becomes part of the landscape. Point Nemo rarely becomes an expedition destination in and of itself. It's not an island to be landed on. It's not an underwater mountain to be explored. It's a coordinate. Therefore, it's most often visited by those already in the South Pacific: circumnavigators, research vessels, and the occasional oceanographic mission. Some pass through by chance. Others deliberately deviate hundreds of kilometers from their route to touch this point. And almost all the descriptions agree on one thing: the moment the coordinates on the navigation screen match, There's no external accompaniment. The ocean doesn't change. The waves move the same. The sky remains the same. There's no sense of arriving anywhere. Awareness comes later. It comes at night, or after a few days when you realize you haven't seen a single light on the horizon. You haven't heard a single radio transmission. You haven't spotted a single ship. On land, even in deserted places, there are often traces of humans. A road, a pole, a plane's contrail in the sky. Here, none of this can happen for weeks. And this evokes a rare feeling, not alarming, but almost philosophical. A world without humans. Night at Point Nemo is especially striking. Away from light pollution, the sky reveals itself differently than above cities. The southern hemisphere reveals constellations rarely seen by those in northern latitudes. The Milky Way becomes a bright band. The Magellanic Clouds are a faint but noticeable glow against the dark background. Sometimes you can see satellites passing across the sky, smooth, silent points of light. And here comes one of the strangest geometries of this point. The nearest people may be not on land, but in space. The International Space Station passes at an altitude of about 400 kilometers. This is less than the distance from Point Nemo to the nearest island. At a certain point, a person in orbit is indeed closer than a person on the ground. This comparison changes our perception of the planet. We're used to thinking of space as distant, but sometimes the ocean reveals something different. Sometimes the Earth is larger than the space above. Another layer of Point Nemo's history is tied specifically to space. Due to its remoteness from shipping routes and land, the area around this point was chosen as a controlled deorbit zone for spacecraft. When satellites and stations finish their work, they can't remain in orbit indefinitely. Their trajectories are lowered, and the remains are sent into the ocean. The South Pacific Ocean became a kind of graveyard for spacecraft, with fragments of decommissioned spacecraft falling there. The Mir station was also sent there in 2001. This creates a strange image. The most remote place in the ocean becomes a place where objects from space return. Underwater, at a depth of several kilometers, lie fragments of metal and ceramics that once orbited the planet. They are gradually being covered by sediment, becoming part of the ocean floor. And therein lies a quiet symbolism. Everything that rises up eventually comes back down. But if we leave this image behind and return to physics, Point Nemo remains, first and foremost, a natural point on the map. Beneath it lies a depth of approximately 4 kilometers. This isn't a record, but it is a full-fledged ocean depth. Cold, dark, with pressures of hundreds of atmospheres. Light doesn't penetrate there. The bottom is covered with fine sediment that falls from above over years. This is sometimes called marine snow. Microscopic particles of organic matter and minerals that slowly descend from the upper layers of the ocean. This is the main food source for deep-sea ecosystems. It was in this region, at the center of the gyre, that oceanographers and ecologists conducted microplastic studies. One might expect such a remote location to be relatively clean. But the ocean is not a collection of isolated pockets. Currents connect the planet, and even here, microscopic plastic particles find their way. They are fewer in number than in northern subtropical deposits, but their very presence is telling. No place in the modern ocean is completely free of human traces. And this is also part of the mystery of Point Nemo, not the mystical one, but the modern one. The place, the farthest from land, still remains connected to civilization through the slow processes of the ocean. But there is a mystery of another kind, a psychological one. Why does this place seem strange? Why do people, even those equipped with instruments, describe a feeling of emptiness, time standing still, and silence that doesn't exist in everyday life. The answer isn't in the anomalies, it's in human perception. We're used to the world being filled with signals: streetlights, road noise, conversations, screens. Even nature usually provides landmarks: mountains, forests, the coastline. In the middle of the ocean, landmarks disappear. The mind begins to notice small details. The wind seems louder, the creaking of the hull more distinct, the splash of the water more rhythmic. The night deepens. Some diaries of circumnavigators describe nights when the sea became almost completely calm. The water became smooth. The sky was reflected in it. The horizon disappeared. It seemed as if the boat was at the center of a sphere, between the stars above and the stars below. Sometimes bioluminescence appeared in such water. Faint blue sparks appeared with movement and disappeared within seconds. This light acts as a small reminder. Even in emptiness, the ocean is alive. Southern latitudes add their own character to this picture. Cyclones can occur here. Storms originating far to the west travel thousands of kilometers without encountering land. Waves can roll in steady, powerful, and heavy waves. During thunderstorms, lightning illuminates the ocean with brief flashes, and for a second, the full scale of the water becomes visible: crests, wave walls, and spray. Then darkness returns, and only sound remains. But the storm at Point Nemo feels different. There's no sense of coastal danger. There are no reefs to crash against. There's only open water. So the storm here isn't about a collision with land, but about the pure energy of the ocean. Yet, more often than not, Point Nemo is perceived as silence, a space where nothing happens quickly, where movement is slow and steady, where time is measured not by events, but by changing light. If I had to describe it in a single image, it would be that of an open horizon that never changes. You could stare at it for hours, and it would remain the same. There's something both calming and disturbing about it for a mind accustomed to variety. Point Nemo isn't a mysterious place like the legends of triangles and disappearances. It promises no sensations. Its mystery lies in pure geography and how that geography influences human perception. This is a place where you can feel the size of the ocean not by numbers, but by its absence. Across the empty horizon. At night without lights. The idea that within a radius of thousands of kilometers there is not a single shore. And in this sense, Point Nemo truly remains one of the most mysterious places in the Pacific Ocean, because it makes obvious what we usually forget. The planet is huge, the ocean is huge, and man occupies only a thin line of presence in it. The Pacific Ocean seems silent when viewed from the surface. During the day, only the wind and waves can be heard. At night, the lapping of water against the side of the boat and, occasionally, the distant rumble of a thunderstorm. But this is only the thinnest layer of sound accessible to humans. Underwater, everything is arranged differently. The ocean is a vast acoustic medium. Here, sound doesn't just exist. It becomes a means of communication and a way to see the world. Sound waves travel faster in water than in air and can travel vast distances with virtually no loss. Where the surface remains silent, a continuous exchange of signals can occur in the depths. The cracking of ice, the sound of underwater earthquakes, the distant calls of whales, the rustling of moving water, even barely perceptible vibrations that only instruments can detect. That is why one of the most mysterious topics associated with the Pacific Ocean is the sounds it makes. Not fantastic, not monster voices, but real acoustic signals recorded by equipment, sometimes very powerful and inexplicable at the time of detection. To truly hear the ocean, it's not enough to just lower a microphone into the water. You need hydrophones, underwater microphones designed to withstand high pressure and long-term operation. These systems are installed at various depths, sometimes kilometers below the surface. They can operate for months or years, recording everything that happens in the ocean's acoustic range. Some of these systems were initially created for security and monitoring purposes. Others were designed for scientific research, monitoring earthquakes, studying whale migrations, and recording ice processes off Antarctica. At some point, oceanographers realized that the ocean makes sounds constantly, but most of these sounds are hidden from human perception. We don't hear low frequencies the way a machine does. We don't perceive infrasound. We're unable to detect faint vibrations amid the background noise of everyday life. And when the instruments began collecting records, it was discovered that the ocean was full of signals that were not always easy to explain at the time of their appearance. One of the most famous cases occurred in 1997. Hydrophones deployed in the Pacific Ocean detected a powerful low-frequency signal. It was unusual for several reasons. First, it was extremely loud, so loud that it was recorded by several distant stations. Second, it had a distinctive shape. The sound seemed to rise in frequency or change over time, resembling an event rather than random noise. They gave him the code name Bloop. The name became popular because the human brain loves to name the unknown. A sound that can't be immediately explained becomes a story. A story attracts attention. In the early years, a variety of theories circulated around Bloop. Some media outlets, not particularly concerned with accuracy, suggested unknown enormous animals. Others spoke of underwater volcanoes. Still others recalled legends of monsters of the deep. But the scientific community took a different approach. If the sound was recorded, it had a physical cause. The problem was that the ocean is vast, and a single sound can have many sources. Low-frequency signals are generated by various processes: earthquakes, ice breakups, the movement of large ice masses, underwater eruptions, even the interaction of waves and wind under certain conditions. Over time, a more likely explanation for the Bloopsation emerged as being linked to so-called ice events, the breakup or cracking of large ice masses in Antarctic waters. When an iceberg cracks, breaks, or capsizes, it can create a powerful low-frequency signal that travels thousands of kilometers across the ocean. This explanation doesn't sound mystical, but it's no less impressive. Imagine a gigantic ice sheet, the size of a city, cracking in the distance. We can't hear it. We can't see it. But the ocean transmits this sound across vast distances, and instruments record it, as if the planet were taking a deep breath. This is one of the main mysteries of ocean sounds. They transform the world into a single acoustic space, where events at the other end of the ocean can be heard here. The ocean sounds different than land because it's a much more homogeneous medium for sound transmission. On land, sound quickly gets lost, reflecting off obstacles and dying out. In the ocean, however, conditions exist where sound can travel very far. There's a phenomenon known in oceanography as a sound channel. At a certain depth, the combination of temperature and pressure creates a layer where sound propagates particularly efficiently. Signals can become trapped in this channel and travel vast distances. This means that sound from a distant event can arrive at a hydrophone thousands of kilometers away and still retain its shape. It can sound as if it occurred closer than it actually did. This is why sometimes it seems as if the ocean is sending signals from the unknown. In reality, these are signals from very distant places. Bloop, Kaich, is the most famous example, but it's not the only one. Over decades of observation, hydrophones have recorded many unusual events. Some of them have been given names because it makes them easier to track and discuss. Sometimes these names sound almost like characters. Julia, upsweep, slow, down. This is not a hoax, but a way to indicate a signal until its nature is clear. Some of these signals are associated with volcanic activity. Underwater volcanoes are capable of producing low-frequency vibrations. Their eruptions are rarely visible from the surface, but they are acoustically noticeable. Sometimes volcanic activity manifests itself not as an explosion, but as a prolonged hum or a series of pulses. Some of the signals are related to tectonics. Underwater earthquakes create acoustic waves that are recorded by hydrophones. This is a kind of underwater version of a seismogram, only in a watery environment. Some of the signals are related to ice processes. The Southern Ocean, adjacent to the Pacific, is a vibrant place. Ice fields move, crack, and break. These processes can create powerful acoustic events that then travel across the ocean. And all this adds up to the feeling that the ocean is a vast archive of events. It records the planet's movements not on paper, but in sound. There is another category of ocean sounds, biological. Whales use sound as a means of communication and orientation. Their low-frequency signals can travel hundreds of kilometers, in some cases, thousands. If you imagine the open Pacific Ocean at night, devoid of ships and human noise, the acoustic space becomes especially clear. Under such conditions, whale calls are clearer. Hydrophones record their songs and short pulses, sometimes even entire conversations occurring far from the recording point. For researchers, this is another key to understanding the ocean. Sometimes, sound alone can reveal what's happening in the water, even when no one can see the animals. And here a quiet mystery arises. How many more signals from the ocean are we missing simply because we don't know how to listen? The modern ocean isn't silent for another reason. Humans have added their own sounds. Ship engines, propellers, drilling platforms, echo sounders, industrial noise. All of this creates a background noise. In the busiest parts of the Pacific Ocean, this background noise is constant. But there are areas where shipping activity is weaker. The southern latitudes, the areas around Point Nemo, and remote spaces. There, anthropogenic noise levels are lower, and in this sense, these areas become important for science. They allow us to hear the natural sound of the ocean more clearly. When research groups talk about the silence of such places, they're not talking about a complete absence of sound, but rather that human noise is less intense. The ocean resonates with its own voice: ice, land, animals, and currents. Even when many signals are explained, the sense of mystery persists, because the ocean is vast and observations are spotty. We record events with an instrument in one place and try to understand what happened somewhere far away. Sometimes this is quick, sometimes not. In this sense, the mystery of ocean sounds isn't about monsters, but about scale and complexity. The ocean connects events across distances that are difficult to imagine. It transforms the planet into a unified acoustic space. And sometimes it reminds us that there are processes that occur far from the eyes, in the dark, under kilometers of water, in places where people rarely go. If you were to find yourself at night in the middle of the Pacific Ocean, far from land, with no lights on the horizon, sound would be your primary reference point. The lapping of water against the hull, the breath of the wind, the occasional crackle of rigging. And somewhere deeper, the low background noise of the ocean, inaudible without instruments, but still present. This is precisely why stories of strange signals are so compelling. They remind us that the ocean is more than just the surface. It's a multi-kilometer deep layer of water where events unfold that are hidden from view. The Pacific Ocean is called Pacific only on maps. In reality, it sounds like this. It holds the voices of ice and earth, the voices of animals, and the voices of the processes that move the planet. And while we only listen to the top layer, the wind and the waves, most of this world remains almost invisible. When people talk about the mysterious places of the Pacific Ocean, they almost always think of the depths, the trenches, the dark zones, the abysses where light never penetrates. But the ocean has another form of mystery, not the kind hidden beneath miles of water, but the kind that lies beneath the surface, in the weather, in the fog, in the unexpected, in how quickly the sea transforms from a calm space into a dangerous one. The Devil's Sea is one such place. It's often called the Dragon's Triangle. Sometimes it's called the Japanese Bermuda Triangle. The name itself creates an atmosphere, as if the ocean here lives by some special rules. And indeed, this place has a reputation that has lasted for decades and is fueled by stories of lost ships, strange phenomena, and a zone where the sea supposedly takes its toll. But if you remove the legend and look at the map, the first thing that catches your eye is the geography. The Devil's Sea is associated with the area south of Japan, near island arcs and deep sea faults. It is home to the Izu, Bonin, Mariana Arc, a chain of volcanic islands and underwater volcanoes extending toward the Mariana Islands and beyond, into the depths where the world's most famous trenches later begin. That is, this is not a random region of the ocean, it is an active part of the planet. Here, the Earth's crust is in motion. Earthquakes occur here. There are underwater volcanoes here. The ocean floor here is not a calm plain, but a complex terrain of ridges, depressions, and volcanic structures. And it is in places like these that the ocean behaves differently. Not because it's magic, but because geology and weather create conditions where the sea can be particularly unpredictable. This part of the Pacific Ocean is home to a variety of water masses. Currents that change temperatures create zones where the air becomes unstable. The weather can change quickly. Fog can arrive suddenly. A wave can grow without anyone even seeing it forming. For modern courts, this doesn't sound like a death sentence, but in an era when navigation was less technologically secure, such areas became sites where disappearances occurred more frequently, simply because conditions were harsher and the chances of survival and signaling were fewer. Therefore, the legend of the Devil's Sea did not arise in a vacuum. She could have grown out of reality. Stories about danger zones often emerge where three factors combine: challenging geography, unstable weather, and a lack of reliable information. If a ship disappears far from shore, in an area with few witnesses, stories gradually gather around the location. First comes a rumor, then a repeating story, then a name. And at some point, the legend becomes stronger than the facts. But the ocean loves such legends, not because it creates them, but because it gives them space. The Devil's Sea is a story about how people try to explain the unpredictability of the ocean. In the 20th century, there were reports of fishing vessels disappearing in the area. Some sources mention expeditions that allegedly set out to explore the area and also encountered problems. However, the reality is more complex. Many stories are poorly documented, many are passed down through retelling, and the term Devil's Sea is often used more broadly than the actual geographic area. And yet, even if we put aside the controversial details, the main thing remains. This area is indeed located in an area where nature is capable of being extremely powerful. Typhoons form and pass south of Japan. Winds can change the ocean in a matter of hours. In such conditions, waves can become high and dangerous, especially for small vessels. Fog, rain, and sudden drops in pressure. All of this transforms the sea into a space where people lose their bearings. And this is where that very atmospheric mystery arises, which fits so well with the style of your channel. Because the ocean at night or the ocean in fog is always a special feeling. Imagine a ship sailing through the water, surrounded by a milky gray fog. The horizon disappears completely. Sky and sea become one. The engine's noise is muffled, as if drowning in the humid air. Drops of water settle on the metal. The navigation lights glow, but the light doesn't travel far. It dissipates after a few meters. At such moments, even a modern person can feel what sailors felt 100 years ago. The sea becomes not a space, but an unknown. And if a ship disappears in such fog, the people on the shore are left with only one thing: guesses. This is how a legend is born. But the Devil's Sea has another layer that makes it particularly suitable for the mysterious places theme: underwater volcanic activity. An underwater volcano isn't necessarily a visible eruption. Sometimes it's a series of weak gas emissions. Sometimes it's a change in water temperature. Sometimes it's an underwater explosion that can create a wave or cause localized changes on the surface. Volcanic arc regions are often associated with unusual phenomena: sudden pumice outbursts, the appearance of floating volcanic rock fields, and mineral-induced water discoloration. Such events could appear as anomalies to those unaware of their nature. The water may appear murky. The sea may smell different. Strange floating fields may appear. This isn't mysticism, it's geology. But in human perception, such things easily turn into signs. Another source of legends is magnetic and atmospheric phenomena. Communication can be lost in areas with severe storms and thunderstorms. This was especially true in the past. If a ship disappeared in an area with weak communication and frequent storms, this reinforced the feeling of a cursed place. This is how human memory works. It identifies danger zones and turns them into symbols. And here it is important not to destroy the atmosphere, but on the contrary, to make it deeper and more honest. Because the ocean's true mystery is often not in its monsters, but in the fact that it remains stronger than human confidence. Even today, with all the modern technology, the ocean is capable of surprise. It can change the weather. It can create waves that seem too big, though they are simply the result of the addition of several wave systems. It can hide its traces because water erases everything. The Devil's Sea is a place where legend arose at the intersection of reality and fear. Not fear of horrors, but fear of the unknown. When there's no horizon, no land, no certainty that the storm will end quickly, a person begins to perceive the ocean as a living being. They ascribe intention to it, but the ocean has no intentions. It has processes, and it is precisely the processes that make it mysterious. There is one thought that ties the Devil's Sea well with the rest of our chapters. The Mariana Trench is the mystery of the deep. Point Nemo is the mystery of distance. The sounds of the ocean is the mystery of what we cannot hear. The Devil's Sea is the mystery of the surface, where the ordinary sea suddenly becomes unpredictable, and together they create a picture of the Pacific Ocean as the last space on the planet that we do not fully control. We can measure depths, we can plot routes, we can listen to the ocean with hydrophones, but we can't make it safe in the human sense, because the ocean is not an object, it's Wednesday, and in some places this environment makes itself felt especially clearly. The Devil's Sea became a legend precisely because people sought to explain its unpredictability. They gave it names, drew triangles on maps, and collected stories. They transformed a sensation into a myth. But if you look more closely, the myth here is simply a shadow of reality. A reality in which the ocean is huge and man is small. A reality where fog can obscure the horizon. A storm can arrive at night, and a volcanic seabed can alter the water so that it looks wrong. And yet the ocean is not evil. He's just not ours. There are mysteries of the ocean that aren't tied to disappearances or legends. They don't rely on rumors and don't need mystical names. These are mysteries that emerge naturally when you understand the scale of what lies beneath the water. The Pacific Ocean amazes not with drama, but with the very structure of the world. Beneath the surface, there exists a relief comparable to the mountain ranges of the continents, and energy sources exist that make life possible where one would think life would vanish. One of the strangest discoveries in oceanography is hydrothermal vents. They're sometimes called black smokers, a name that sounds almost fairy tale-like, but the reason is simple. Superheated water saturated with minerals emerges from cracks in the ocean floor, and when it meets cold seawater, the minerals instantly precipitate, forming dark, billowing columns. From a distance, it truly does look as if the ocean floor is smoking. The most important thing here isn't the spectacle, but the meaning. On the ocean surface, all life is ultimately connected to the sun. Plants, plankton, photosynthesis. In the depths, there is no sun. Starting at about 200 meters, the light quickly fades, and beyond that, kilometers of darkness follow. For a long time, it seemed that life at such depths could only be a sparse extension of surface life, some feeding on what falls from above, others surviving slowly and economically on the remains of organic matter. Hydrothermal vents challenged this logic. It turned out that life can exist without sunlight at all. Where hot water emerges from the depths, it releases chemical compounds along with it, and microorganisms have learned to use them as an energy source. This isn't photosynthesis, but chemical metabolism, chemosynthesis. Essentially, an ecosystem emerges in such places that is independent of day and night on the surface. It's like a separate island of life within the darkness. When a deep-sea vehicle first approaches such a field, the sight is memorable precisely because of the contrast. All around you is blackness, cold, and the empty expanse of water, and suddenly an oasis appears ahead. Clusters of living creatures, white tube worms, mollusks, crustaceans, all around vents that look like underwater factories. And you understand that the ocean creates life where it seems impossible, simply because the planet has warmth within. The Pacific Ocean is particularly rich in such zones because it is the ocean of the Ring of Fire. A belt of volcanic and tectonic activity runs around it. Where plates collide or diverge, cracks and hot vents often form. Sometimes hydrothermal fields are discovered suddenly, as if they weren't even on the ocean map. And in a sense, this is true. The ocean is vast, and such fields can be scattered, isolated, and hidden. They can't be seen from the surface. They can only be detected by instruments, chemical traces, temperature anomalies, water turbidity, and plumes, clouds of particles carried by currents. And here's where a subtle mystery arises, one that suits your channel. We live on a planet where beneath us are worlds whose existence we've only recently discovered, and which we still don't fully understand. We know the principle. We know there's life there, But we don't know how many more such places are hidden in the Pacific Ocean. What species exist there? What forms of symbiosis nature has devised? How many more islands of life lie hidden in the darkness? Second place is a different kind of mystery. It's not about life, but about topography. When people think of the ocean, they often imagine a flat blue plain. But the Pacific Ocean floor is a vast mountainous region. There are ridges, plateaus, canyons, volcanoes, and entire chains of underwater mountains that stretch for thousands of kilometers. Some of these mountains are so high that on a land scale they would be great peaks, but they have never seen the light of day because their peaks remain deep underwater. Seamounts don't seem mysterious on a map if you're used to numbers. They seem mysterious when you realize there are so many of them, and many of them are barely explored. We know they exist because we can measure depth and map the seafloor. But knowing they exist doesn't mean understanding them. A seamount isn't just a rock. It's a place where currents behave differently, where nutrients are trapped, where life emerges, where local ecosystems can develop. When a current encounters an underwater mountain, it rises, swirls, and mixes the water, bringing nourishment from the depths closer to the surface. This causes fish to gather around some underwater mountains, creating entire islands of life in the middle of the ocean deserts. To the ocean, it's almost like an archipelago, only invisible. And there's another layer. Many seamounts are volcanic in origin. They're traces of hotspots and plate movements. Some seamount chains are like imprints of the planet's past movements. A volcano arose, a plate moved, the volcano died out, and a new one arose nearby. This is how entire mountain ranges formed, extending into the ocean. We see them as a geological memory. If you imagine deep-sea photography near the top of an underwater mountain, it feels nothing like the ocean floor. It's like the slope of a real mountain, only in water. Rocky ledges, scree, sparse life forms, a deep blue darkness to the side. The spotlight beam picks out the surface, and beyond is nothingness. And the strangest thing about it is that the scale isn't immediately apparent. You think you're next to a small hill, but on a map, it could be a mountain several kilometers high. And that's when these two places, hydrothermal vents and seamounts, begin to sound like one story. The ocean doesn't just conceal depth. It conceals the architecture of the world. In some places, this architecture generates life through the planet's heat. In others, it forms invisible islands for currents and organisms. And all of this exists whether we look at the ocean or not. This is the quiet truth of the Pacific Ocean. Its mysteries aren't necessarily found in legend. Its mysteries lie in the fact that it's too vast to be fully understood, and in the fact that beneath its surface lie spaces comparable in scale to entire continents, yet remain nearly invisible to the human eye. When we talk about mysterious places in the Pacific Ocean, it's easy to imagine a map with marked dots, as if the ocean were a collection of individual stories. Here's a trench, here's a remote point, here's a legendary zone, here's a strange signal. But the longer you look at the ocean as a living system, the clearer it becomes. These places don't exist in isolation. They are connected by one thing: scale. The Pacific Ocean is so vast that human attention to it will always be spotty. We can study individual areas, lower submersibles into the abysses, conduct expeditions, listen to the depths with hydrophones, and map the ocean floor. But all this is like a flashlight beam in the night. It illuminates a small circle, while everything else remains in darkness. Not because the ocean deliberately conceals this, but because it is truly vast. The Mariana Trench reveals the vertical. It reminds us that the planet doesn't end at the surface. that beneath us are kilometers of water and kilometers of crust, that the pressure can be such that a human being can only exist there as a guest inside a small metal shell. This depth shatters conventional notions. It makes the concept of far physical. Far is down, where there is no light, where time feels different, where movement is slower, and life seems as if it were invented anew. Point Nemo shows the horizontal. It reminds us of the distance that can't be felt in the city. There's no land within a radius of thousands of kilometers, and at some point you stop perceiving the land as something close. It becomes an idea. You understand that the ocean isn't the space between continents, but a world unto itself, occupying most of the planet. Point Nemo isn't frightening. It simply makes it obvious. There's a place where the ocean is all that exists. The strange sounds of the ocean remind us of another dimension, that we not only see little, but also hear little. On the surface, the ocean seems silent, but beneath the surface, it constantly speaks, with ice, tectonics, living creatures, the movement of water. Sometimes a signal comes from far away and sounds as if it's nearby. Sometimes it can't be explained immediately because the ocean is a vast acoustic medium where events stretch over thousands of kilometers. And then a special mystery emerges that doesn't require monsters. The mystery arises simply because we're not used to listening to the planet as a whole. The Devil's Sea reminds us that secrets exist on the surface too. In fog, in storms, in unexpected weather changes, in volcanic activity underwater, in places where legend has grown out of reality. Not because the ocean takes people, but because the ocean can be unpredictable, and humans are weak in comparison. Legends are born where there are few witnesses and much remains unknown. And the ocean has always provided people with plenty of unknowns. Hydrothermal vents and seamounts reveal hidden architecture. They remind us that beneath the smooth blue surface exists a vast country of ridges and slopes, of hot crevices and cold plains. There are places where life is independent of the sun. There are places where currents are altered by invisible mountains. There are ecosystems that live their own rhythms, oblivious to what's happening above. And when all these stories come together, what emerges is not a set of mysteries, but one overall picture. The Pacific Ocean is Earth's last unknown world, not because we're lazy about exploring it, but because it's impossible to explore quickly. It takes time. It requires technology. It requires patience. And even then, it will leave vast expanses unexplored. There's a quiet thought that comes after such a journey. We're accustomed to thinking that the world around us is understandable because it's measured. But measurement isn't understanding. We can know depth and not know what lies in that depth. We can know coordinates and not understand the sense of space. We can record a sound and not immediately understand what produced it. The ocean reminds us that the planet has a life of its own. It moves water through currents, transports heat, stores carbon, maintains the climate, creates storms, and nourishes vast ecosystems. It makes life on land possible, even if we rarely think about it. And there is a special piece in this. The ocean requires no explanation from us. It simply exists. It was here long before us and will be here after us. It will slowly move the water, build new landforms, destroy old ones, hide and reveal. We can only occasionally peer inside with a beam of light, a device, a sensor, an expedition. And every time we look, the ocean reminds us, we don't see everything. Perhaps this is why people are so drawn to stories about mysterious places in the Pacific Ocean. Not because they want to believe in fantasy, but because they want to feel the scale, to sense that the planet is larger than the world we live in. that there are spaces where humans don't control everything, where they're not in charge, where they're simply an observer. And if you imagine the ocean at night, the dark surface of the water, the stars above, the absence of lights on the horizon, it becomes clear. The mystery is sometimes not in the event, but in the silence itself. The Pacific Ocean doesn't necessarily tell stories loudly. It does so slowly, through distance, through depth, through sound, through the absence of landmarks, through rare points of light, bioluminescence, a fire on the horizon, a satellite in the sky. And in this slow language of the ocean, there is something for which people return again and again. The feeling that we live on a planet where truly unknown spaces still remain. And perhaps it is there, in the very depths, in the most distant place, in the quietest and darkest, that the ocean holds its future discoveries. Not as mysteries to be solved, but as a world that we simply need to continue to see, listen to, and respect.